Welcome, everyone. I'm Zhiyi Yu, the structural engineer and professional engineer. This topic is probably will be four topics. One is foundation analysis and design. Second is structural steel engineering. Third is Vancouver Lanway House. And the last one is light gauge steel building. So first will be take a look at the several kind of the building. This is a common, the concrete and steel reinforced concrete. This is usually used for the high building, high rise and commercial building. And because it is strong to resistant the seismic load. And this one is a steel. It's a totally steel construction, steel building. And apart this concrete steel, and we got another steel. This is use the open web joist. This is usually for the commercial building. And this one is a wood construction. I will say this one is combined, because the foundation usually is concrete, and the wood for the star, and the wall and flooring and truss is a wood. So we're talking about some loading there. There are several kind of the loading. The loading usually divided as two kind. One is a live loading, and another one is dead loading. So for the live loading, there are several kind of the live loading. The live loading, it means that they will changeable according to your function, according your location, orientation. And the live there's another kind of the loading is seismic loading. Seismic loading means when the earthquake happened, they have the horizontal force and the vertical force and the horizontal and the vertical combined force. So the very hard loading to think about is a seismic load. Sorry. Seismic loading. And the live loading, usually we have the rain loading and the snow loading. For the wood, for the roof, to resist the live load, the rain loading and the snow loading. The snow loading is take a look and to focus on the snow loading, because the snow will be combined, also will be according to the different location and the different season is different. This is a loading. Now we will think about the design of the foundations, because the loading is from the top to bottom. So the good design for the structure is to get the loading, all the loading to transfer clearly from top to bottom. So the bottom will resistant the loading is a foundation. The foundation, we can have the simple calculation. The foundation usually is concrete and reinforced concrete, so that foundation is strong enough to resist loading. But the loading, the foundation will transfer the loading to the earth, soil. So soil is very important to think of the soil bearing capacity. For the wood construction or the house, if we don't have the just like the Richmond, if we don't have the basement, the bearing capacity usually is 1,000 psf, 1 square feet is 1,000 pound. And we think about the foundation. The foundation will give you something to take a look. So this is a beam, is a simple supported beam. The foundation looks like the symbolize the footing or foundation. It looks like the beam. So the beam, two end we have the support, and at the bottom we have this is a simple beam. So if we don't have any support in the middle, the moment just like this. If the beam is have the support in the middle, the moment will change. So the foundation looks like all the several support or the continuous support from the bottom depend on the situation. So if all soil capacity is keeps the consistent, keeps the seam continuous, so that moment will be just like the some rectangular something. Yeah. So we'll take a look at some foundation situations. So the worst is a differential settlement. The settlement is because the building have the load, building have the weight. So as long as the time for 1 year, 2 year, so they will squeeze the soil. Is a settlement. But if the settlement is same or the differential is small, we can see is a regular settlement. But sometimes the settlement is over some limit, so you can see the foundation have the crack. In case they has crack, the foundation will be filled. In case the crack happen, we usually have the reinforcement. So we have several reinforcement for you see this is a basement. The basement have the foundation wall, have the footing. So we have the reinforcement. So this all the foundation wall looks like the beam. So no worry about the settlement, the differential. To resistant the differential settlement. That's the foundation. There's several kind of the foundation type. So we have the shallow foundation, means the footing, the strap footing. We have the foundation wall combined with some footing. This is usually used for the basement. This is a typical foundation. So we have the foundation wall. We have some cell plate here. The cell plate usually depend on the city. For the Richmond, the start is 2x6, so the cell plate usually is 2x6. The cell plates we need put some hold down. The hold down function is very important. The function is to hold down some lifting force. When the wind or seismic happened, there's some lifting force. So the hold down is very important to resist the lifting force. There's another bolt. So they have the bolt to anchor to the foundation wall. This is a typical section. There's several kind of the supporting method to take care of the beam or open web joist and the steel beam, wood beam. They have some pocket here to support, to take the enough support for the beam. There's a kind of the typical framing here. So we got the start. Usually the start is spacing is 16-inch. Depend where city. If the Vancouver is 2 feet bracing for the start. Also for the Vancouver the start is 2x8. There's a cell plate, there's bolt here, so they have the corner connection here. Is a typical framing for the main floor. Yeah, this is a pocket. It's a beam pocket. This is very common. So this is a site picture to show the reinforcement, the rebar. The bar spacing is usually is 40-inch, and the footing usually have the 3 bars. The top have the 2 bars. You see the 2 bars is narrow. That's it. When the reinforcement is complete and the form complete, they have the inspection for a city. If approved, they will pour the concrete. Yeah, this is a form. The form is complete, so we'll after inspection we'll put the concrete here. This is a typical foundation section here. You see here, the footing usually is 2 feet. 2 feet T section here. So they have the horizontal and vertical bar here is a 40-inch spacing. So after that, they have the TJI or the 2x10 and joist. They have the sheathing here, and we have the light concrete. Put the floor, concrete floor. It's very common. this is a very common section for the window well. Sometimes the basement we need the window well. So yeah, the window well we have the PSL header here to support the above the stud wall. It has a sunken patio. This is a same thing. This is a door here, door opening, so you can access to outside. This is a sunken patio. In the Vancouver, some smaller house, they usually have the sunken patio. Design the sunken patio. So the differential here is from internal and external is a 6-inch minimum. This is another one. Another typical section here is to setback. Main floor, they setback, so they have the deck to cover the basement. There's another one. If we span is too big, for example, is a 30 feet span, the wood beam or PSL beam, parallel beam, doesn't work. So is over 25 feet doesn't work. We need a steel beam. This is another project we did before. We have the steel beam here. We'll talking about the steel later. This is a steel beam, and the steel beam we have steel columns. This is a typical section here. Is a connection, welding connection here. The commonly used, we lower the base plate. Why? Because if the base plate is top, the bolt will be exposed. It's hard to cover. So we lower down the footing, the pedestal. So the from inside we cannot see the bolt. This is another one is a setback from the basement. We have used the steel beam. This steel beam is sitting on the floor, sitting on the foundation wall. There's several kind of the typical here for the steel beam to sitting on the foundation wall. So this is a topic for the. It's just the general topic for the foundation. Yeah. Now we will change to another topic is living house for the Vancouver. The Vancouver we usually design the living house because they can to economically use your lot to have the two house, the main house and the living house. The living house is very small, but they still have something to think about. Is economically to get your space to use. Living house. This is one kind of this one is completed. Is very small. Usually we but don't have the basement. They have just the footing, but the external wall is same thing. Use the 2x8 start. The living house is a very for the framing is a very tough thing is how to some shell is the window, because sometimes they will raise up your rafter to have the shelled dormer. This is a kind of the typical design for the shelled dormer. The dormer is the sloping is 312, but the main slope is 712, so we'll raise up. There's this is a 3D to show how the shelled dormer to framing the shelled dormer. So here we will get some double or triple the rafter to framing the shelled dormer. There's another dormer, is a gable dormer, another kind. The living house is we don't use the truss because the span is very small. The truss is hard to fabricate. So the living house we just use the rafter to framing. Another thing is the living house is a bay window. The bay window is because the bay window the box sometimes doesn't work, very small, so we still use the rafter to framing the whole bay window here. The bay window, we think about the bay window design, the structure design is we'll focus on some projection here. The projection there's limited. The 18-inch the projection usually for the building code, but if we have the more projection, we need a brace here, put some brace here. We usually see some photos in the street, we have the bracing here, looks like this shape. This is a shelled dormer, another shelled dormer to framing here is the same thing. So living house is very small, but there's a lot of the tips for the framing the dormer, framing the wall, and framing some openings. Now we will talking about some steel construction, structural steel engineering. Before we talking about the structural steel engineering, and we'll think about the comparison with some buildings, different materials. Why we use the steel for the building? Because there still have the several kind of the advantage. First thing, steel is light, and second, the steel have the advantage for the shop fabricated shipping to the site, and have the installation. So they have the shop fabricate, so this is accurate. Another one is steel have the advantage to take the more seismic force. So for the earthquake happened the areas, the steel engineering and steel construction usually is a kind of the main method to take care of the earthquake. Also the steel building can constructed to the high rise height. There's some kind of the combination, but the concrete, reinforced concrete still can resist the earthquake, but there's some height limit. So there's some combination. For the steel, we use the outside wall is a steel, but the inside, the core stair tower, we use the concrete. But there's this disadvantage for the steel. Steel is a fire. The fire can destroy the steel quickly. This is a general speaking for the steel construction. Still, we have the same thing with compared with the other materials. Is same thing. We have the steel column, we have the steel beam. Is a girder, is a main beam, and the main beam we have the secondary beam, and the secondary beam we will support the floor. This is another one, is a steel construction for the shop, for the commercial building. So for the building, we have the same thing. We have the column, gird, beam. We have the purlin to support the roof. We have the roof truss here, and roof purlin, and roof slab. This is we are talking about some typical structural steel framing here. So we have the for the steel we have the two, mainly we have the two connection. One is a pin connection. The pin connection means we cannot resistance the moment. So the just the shell resistant shell, so the pin connection. And there's another one is a moment connection. So this connection is a pin connection. We use angle to have the bolt connection here. Bolt connection usually is for the pin connection. So this is commonly the column and the beam connection, pin connection. We have the beam column should be bolted to the concrete footing or pedestal. So we use the column, we have the base plate, we have the bolt. Usually this is the basement connection usually is a moment connection. So the bolt should be outside the column. This is a basement, is a base plate connection here. There's another one is a gird. The main beam here is a secondary beam, and we have the floor. The steel building, the floor we usually use the concrete, because the steel can transfer the sound and transfer some shaping, so we use the concrete because it is light. For the stairs and for the floors, we use the concrete topping. This is a building for the residential building, house. We use the steel construction. The steel can have the big span, and so the wall is not the bearing wall here. So we don't need the wall to bearing some floor and some roof. So it looks like it's a very commonly used for some view area. So this is a steel drawings. For the steel engineering, we have the task. So we have the calculations of loading, and we will design the concrete foundation, and we have the calculate the steel beam, steel column, and some connection. This is a steel base plate plan. So in these drawings we'll show the dimensions, show the size, and we'll show some connection here. This is a detail, a typical section detail. We'll show the elevation to connect, and we show some connection, some connection member here. Also we'll show some welding. If the connection is welding, we'll show how to weld and weld length. This also here is a typical section here for the steel construction, and I see is a combination for the steel beam and the wood joist. So we would wood joist here. This is a steel construction for the smaller building. All the main gird column is exposed to the outside. We have the corner, we have the brace. For the several bay, we just have the one corner, have the brace is enough to bracing. Bracing means make the framing stability. It's not the bearing consideration. It's just for the stability. There's some steel drawings for the just partially to show the steel base plate plan. We usually have a steel base plan. We usually have the plan for several elevation. We have the plan. If the multiple story of the building, we have the several top of steel elevation plan. Also, we have the section to show some connection here is and some flooring system, or what kind of floor system we used. This is a moment connection. Commonly used the moment connection here is very common. Is a column, is a beam, so is a welded beam is welded to the column. So this is a site welding. We cannot use the weld to the shop. Weld beam and column welded to, if we were welded to shop, is a very big. Is a shipping is hard, is difficult to ship all the buildings to site. So the welding usually is a site welding, but the site welding is labor, uses more labor, is expensive. So for this kind of the connection here, we usually welded the plate. The connection plate is a sharp, and welded all the plate is sharp, and the site shipped to the site, and bolted the connection is the site. Yeah, this for the steel construction, steel connection. There's several kind of the steel connection here. The steel connection, the shop have the commonly used the connection for the engineer. Just give the column. The engineering is calculate the column size, beam size, and the connection force here. So the shop can be take care of all the fabrication here. Is a beam, is a main beam and the secondary beam connection is same. If the flashing with the girder and the secondary beam connection here, we can use the welded flange, some connection here to tie the two kind of the different height the beam here. This is a beam to support the beam connection here. So the bottom beam is a girder beam, is a big, and the top beam is small. So the beam sitting on another beam, we have some buckling happened here. So we to prevent the get rid of the buckling here, we add the stiffener here. Yeah, both sides we have a stiffen to weld it to the flange and the web. Also, we have the several kind of the wood post to support the beam here. These are from the site. It's very common. You see the steel beam we think about the connection here. So the joist, the wood beam to connect to the steel beam is hard. So we add some plate here to inside the steel. So it looks like the steel beam is a wood beam. So they can connect to the floor joist easy. The steel floor systems, we just use the metal decking. the mantle decking is two kind of the functions. One is for the to support the concrete, to make the pull the concrete easy. Another one is the form. Also, the mantle deck is for the reinforcement. Just like the rebar is same thing rebar. So they combined the concrete and the mantle deck together is a composed floor system. Sometimes we have some mantle net inside the concrete, so they have the two kind of the top reinforcement, and the bottom we have the mantle deck reinforcement. So this looks like the sandwich or composed concrete flooring system. This is a kind of the steel design plan. So we in these drawings we show the dimensions and all dimensions and the size. So the column size and the beam size. Also we need to mention the force here, the two-side force. Sometimes the one kind is different with another kind. Yeah, this is the same thing for the steel drawings. We show all the engineering member, size, force. These are typical. This is a shop drawing. The shop drawings usually take care of all the connections. For the engineering structure, engineers don't take care of all the detailing. Just show the size. The steel drawings just show the beam size and the elevations. The shop will be take care of all these connections. We just give the engineering drawings, just show the size. So this one is a shop drawings. They will fabricate according to this detail. So they will cut the beam, the size, and the dimensions, and put the secondary beam in the correct elevations. They will add the angles. They will weld the angles, have the drill the hole, also, and put some bolt here. This is another kind of shop drawings. The shop drawing will be draws all the member. It doesn't matter what kind of the member. They will draw all the members. So they ship all the members to site and install the members to get the construction done. This is a deck. This is a steel deck. This is from Richmond. I just walking for River Road to get this picture. This that one is a cantilever steel construction. For this project, I think the wood construction doesn't work because this span is the projection is too much. I can have the simple calculation here. So the guard is probably 4 feet, right? So that one is 4 feet, so it is a 4 feet, 8 feet, probably 10 feet. So 10 feet is a 3 meters projection. The wood construction, the cantilever, the limit is 4 feet, so is 10 feet. So should be take the steel beam, cantilever beam, to take a look, to take care of this kind of the decking. Also, we can see the steel advantage is the size is small. For this kind of the 10 feet projection cantilever, the size I think there's just is less than 1 feet, right? Is probably 8 inch. So the 8-inch steel beam can cantilever 10 feet. Yeah, that's a steel advantage. You see the connection here. So we have the steel beam here. We have the base plate here. The base plate thickness is usually is 1 inch. I think it's 1 inch base plate here. So the beam is welded to the base plate here. Also, we have the stiffener here. We use the bolt here. I think the 4 bolt here. The bolt diameter is usually is 1 inch or 1 inch. So for here, we see the 4 bolt is enough to take care of all the cantilever beam. Is a typical cantilever. Yeah. Oh, there's another one is a footing. Is a concrete wall is for the basement. If we have the windows here, we need the step the concrete wall here. This is a typical stepped concrete wall here. There's another one is this one is for the truss. Yeah, it's a combined truss here. Sometimes we use this one for the foyer. Foyer, we have the different foyers. We have the openings here. We have the dropped the truss here, and we raised up truss here. So we combined the 2 truss. For the for some house, we usually use the combined truss to take off the different elevations. Is a ceiling elevations, different ceiling elevations we take care of. Yeah, this is we have the general talking about the steel building, and I think we can shift to the another kind of the bigger topic for the light gauge the steel building. Yeah, I think we can rest. Take a rest of the 10 minutes. So we are talking about the light gauge steel building. This is a very famous for this building because this kind of building can span a big and we light. Also we can fabricated in the shop and to ship to the site to mount it to the foundation, the concrete foundation. There's here we just general speaking for the light gauge building here. We see here the framing is light steel and the outside wall is wood, so we'll see the framing is steel, all the steel, and we can have the roof and the truss to fabricate it in the shop, and the column and the beam and fabricated in the shop and shipped to site, and bolt connection with the all the bolt connection. So we'll see the here with a light steel construction here. The foundation is still the concrete. So we have the start. Start is use the C channel here. C channel start. C channel start here. We have the C channel start wall here. So we have the opening here for the windows. Everything is the same with the wood construction, just the material different. And we also use the rafter. Rafter is a C channel here to framing the roof. So we got the, we can see the light gauge steel start are manufactured by cold framing sheet, steel sheet, strap steel. The cold formed steel start can be easily cut and assembled with the simple tools into the wall. So you can simply use the simple tools to install the light steel start. The C channel is very light. Is light than the wood structure that is lightweight, non-combustible, so it can resist the fire. The wood house is some fire combustible, right? And drip proof. Metal stud walls may be used as the non-load bearing wall. You can use the load bearing wall or the non-load bearing wall, or the non-bearing partition wall, or as the bearing wall supporting the light gauge. The bearing wall is looks like same with the wood construction, so they just start the different. Start is a C channel. To have the C channel, they put the sheathing, they put the drywall. It looks like same. If that one is constructed complete, they have looks like the same with the wood house, but it is a steel house. Totally is a steel house, different. Yeah, this kind of the framing. This is a completion, the construction completion here. So we can see the, we're talking about the light gauge steel construction totally, and the detailing here. This is a concrete foundation here. This is a C channel start. So the spacing is 12-inch 16 inch or 2 feet. Is same with the wood start, but is light. And they have the here we put some bar here, stable bar here, just one stop here. Also we need the brace bar here. Let's see another one here. So it's a foundation, right? Foundation is same thing. We have the bolt. We have the C-channel start here. So there's a continuous range channel. We have the bolt here, bolted to the foundation wall here. So we have the C-channel start here. Is the top. This detail, this section is typical. Is the same with the wood construction. Also we have the opening here, so we put the truss header. This header usually we use for the wood construction is a 3 2x10 for the header, but now we use the 3 2x10 still heavy, but for the truss header the light gauge still is light. The is very light. You see the detail here for the header. It's just the C-channel here and the C-channel here, different direction here, and put some gusset plate here. So this is easy to install and construction here. For the topping, we just use the concrete topping. And the concrete, there's another way why put the top. The concrete is fire resistant, so we need the also the sound resistance, sound stopping for the concrete here. This is some typical section here for the light steel construction. Here is a floor projection and openings. So if floor have the projections, for the C-channel we have the more projection than the steel beam. Here we have the C-channel for the wood construction. We use the cell plate 2x6, 2x10 or 2x8. Now is use the C-channel for the cell plate, just upside down the C-channel. We have the C-channel here, and we have put the start inside. Also we have the reinforced mantle deck. Is same thing with the heavy steel construction. We have used the mantle sheet here. We put the concrete top. Yeah, that's the floor system. Also we can use the share the wood construction here. This is a combination. So sometimes we use the combination. Is the same thing for the C-channel web stiffener here, C-channel beam, C-channel beam here. We put the sheathing here, and we put some start here. Is the same thing with the wood construction. Here is an internal wall here. So internal wall for the wood construction, internal wall, we put the two joists here. But here we put the double channel together to support the internal wall here. Here is an external bearing. We put the primer closure channel here to support the external wall here. Is a typical section here. And there's another typical section here from internal bearing. So with the comparison with the wood stud framing, we can see the light gauge steel framing is simple, and it's the same thing. It's easy to install site and DIY. Now we will show, generally speaking, the joist framing. So joist framing, this is a typical section for the light gauged joist. So the web we in order to make the joist lighter, so we drill the big hole here. So because the web is we made some big hole here, made the joist lighter and stronger here. Just looks like we have the stiffener here. We separate the stiffener here and connect all the stiffener here, so it's making it stronger. This is a 3D view to the framing here. We have the joist here to have the spacing here to framing all the floor. So the light gauge steel joists are laid out in and assembled in a manner similar to the wood joist framing, right? So the joist spacing is similar with the wood joist framing, is 16 inch, 2 feet and 4 feet. But the wood, I don't think the wood joist framing is to get bigger than 2 feet, right? So usually 16 inch. Spanning capacity of the floor deck. The connections are made with the self-drilling, self-tapping, and screws inserted with the electric and pneumatic tools, all with the pneumatically driven pins. Welded connections are also possible. So welded connections, sometimes we need the welding connections. There's another one we show the how to framing the light gauged steel joist. So we have the start here, we have the opening. Sometimes we have the opening here for the windows or for doors, and we need the just like the wood construction, we need the header. And sometimes with the C-channel joist can cantilever a little bit. The strap bridge prevent the rotation or lateral displacement of the joist. Spacing 5 feet and 8 feet. For the wood construction, we still have some strap. The strap spacing is 7 feet. This is some typical section on the section here. So this is a C-channel start. For the C-channel start, the size we use the several kind of size depend on the span, the shape of the building, and the some place of the building to framing use the C-channel start. So the size is different, but the commonly used is a 38 take. 38 take for the C-channels is a 1.5, right? Is 1.5 inch. So 1.5 inch is usually used. The height we usually use the 8 inch. This is the corner framing. For the wood constructions, we use a stud like this to framing the corner, but we can use the same situation. We can use the C-channel to framing the corner. Here we can show some detailing for the light gauge steel wall here. So we have the along the foundation joist here. We have the vertical joist with the 16-inch spacing. Joist here is vertical joist. And we also have some insulations. Some insulation is to stop the light transfer, stop the sound transfer. So is a sound stopping. We use some insulation here. Also, we have the insulation for the to take care of the energy efficiency insulation. We have the drywall here. Also, we have the drywall, the internal drywall here. Also, we have the sheathing outside. We have the water stopping. Also, building paper. So for the light gauge steel joist, we usually use the C-channels. C-channel is why we use the C-channel, because the C-channel is economical, and the C-channel is light. C-channel also is easy to fabricate. They can use just in the shop. We can use just steel sheet to fabricate the C-channel. It's easy and economical to. Let me think about why we use the C-channel to the joist. We can have the comparison for the span. So for the span, for the 6-inch joist here, we can see the span is 10 feet or 14 feet. Let's have the comparison for the 6-inch 2 by 6. The 2 by 6, the span is usually is is 8 feet, right? So the 6-inch C channel is 10 feet. Is more span. There's more span, more cantilever. We can see the 8-inch C channel. We can span to 18 feet, but the 2x8 is only for the 10 feet, so it's a more span, right? There's some up is estimate the span for the C channel here. There's some so there's a comparison with the wood construction and the steel construction. We can see some characteristics for the wood construction. The wood construction is the only advantage is the material. The material is light, is easy to get. Also the wood, we have the several kind of the fire resistant, and also the wood we can see the wood have the good capacity for the seismic resistance. And also we can see that there's a long history for the wood construction. That's the wood construction. But we can have the comparison with the light gauge steel construction. So we can see the one advantage with the comparison with wood construction is a very free, convenient to have the your plan for your spacing arrangement. So they have the more function to satisfy your multi requirement for your spacing, right? And what another two is light is very strong, light, strong, and more seismic resistant, and safety. Third is the construction is speed. Construction speed, and is quickly, and another one is you can have the more fabricated in the shop and move and ship to the site. So is we can see the industrialized is a shop drawing, they shop fabricate. So is we can make this construction is standard construction, and so whatever you are, what season you are, so you can have the same standard for the, because it's a shop drawing, a shop fabricate is have the same level standard for the building. Yeah, I think that's all for all the topics for this tonight. So we can have the talk, and to focusing on this kind of the topics, we can have talk. And if you have some questions, and just ask. So maybe we can change the ideas, change the topics for all this one.